one. Boom!
Live na.
Yes,
We're
we're
live.
live. Welcome to the powerful Komiksman podcast. Yun. We're back, and it's a wonderful day today. Wonderful afternoon kasi natupad na naman ang isa sa mga pangarap ko. I still can't believe that people go out of their way. These people that invite, which are awesome people, I can't believe that they go out of their way to visit me here in my studio and do this. And ang naisip ko lang na sometimes I wonder the only reason that I could think of is that they're really that passionate about what they do, and they want their message to be heard. Yun. So I'm really grateful to all of my guests from the first time, from the first episode that I started having guests. Anyway, yun muna. First of all, if you're watching, wala pang nanonood, if you're watching, please, you can join the conversation by commenting. Just ask us, me and especially my guest, just anything na gusto niyo itanong, and please do share and like the page for more Pinoy podcast stuff. For more content na ganito, kung medyo sumama kayo dun sa ibang klase ng nakikita nyo everyday, I think this show is a little bit unique compared sa what you can see normally on Philippine media, either in social media or in mainstream media. Anyway, yeah, we are also in IGTV. I upload clips there, not full episodes kasi mahaba yung full episodes. But full episodes are also available in YouTube channel. Just search Komiksman on any of these social media platforms, and you'll find this show. And and of course, our forever sponsor, Yucha Lux Cakes. Yun lang ang spiel ko. I'll go ahead and introduce my wonderful guest. Um, I heard one time, isa sa mga favorite people ko in the internet all over the world is Neil deGrasse Tyson, and he said in one of his talks na astrophysicists are literally one in a million. So if you ever get the chance to to meet someone, that is the time to ask all your questions. And for me, the time has arrived, and I am proud and deeply honored to introduce Miss Reina Reyes.
Thank you for
Yes.
having me.
Yeah. Reina, of course, is a Filipino astrophysicist and data scientist, right? So one of our top scientists is in the studio, and we can talk to her. Yan. So yeah. Well, Reina, you parang yung how I learned about you was when I saw the Rappler article about your paper on Einstein's general relativity. Yun. Tapos you discovered something about it. Can you tell us about that?
Sure. Actually, it's been a while. It was part of my PhD thesis. Um, it yes. Sige. So I'll tell you about it. Basically, Einstein's theory of general relativity is the theory that, di ba, that governs how the universe evolves.
Mm-hmm.
So in particular, how galaxies cluster together,
Mm-hmm.
and how the universe expands. And yun nga, we discovered that it's expanding faster and faster. So the expansion is accelerating.
Wow.
And it was actually a surprise for for all cosmologists, for
Mhm.
the scientists, and the team that discovered this eventually won the Nobel Prize.
Mhm.
Um, so the question is, why is it accelerating?
So it is accelerating. So from the Big Bang, 'di ba? Parang you would think na parang constant lang yung speed nung pag-move ng mga
Right,
galaxies.
yung expansion niya,
Oo.
and in fact, the expectation was it will slow down
Mhm.
eventually
Ay.
because of gravitational effect. Diba? Gravity is always attractive, diba?
Mhm.
So if you have two masses, or we are being attracted to the Earth, that's why
Mhm.
we're not floating.
Mhm.
So if you look at the cosmological scales, cosmic scales, eventually the matter will attract one another, and the expansion would slow down.
Mhm.
So that was the expectation.
Mhm.
But in fact, what we found was that it was speeding up.
Mm.
And so the question is, um, how do we explain that? And one of the explanations, and that's the most popular explanation, is that um, there's something, or scientists introduced this concept of the dark energy.
Mhm.
Um, but the fact that we call it dark energy, dark means we don't know what it is,
Mhm.
like mysterious, right?
Mhm.
But basically, what it does is that it has like a repulsive force that counteracts gravity, and
Mhm.
that's what is making the universe accelerate.
Okay.
But there are alternative possibilities, right?
Mhm.
And one possibility is that the theory that you're actually using could be wrong.
Okay.
So in this case, it's Einstein's theory of general relativity. So what if, on cosmological scales, you have, in fact, a different theory, an alternate theory of gravity, which predicts the acceleration?
Ah,
And
okay.
some theorists have proposed such theories.
Mhm.
So they're called, right now, they're called alternate theories of
Okay.
gravity. Um, and in fact, we haven't really, so of course, the general theory of relativity has been explicitly tested, and in fact, we need to use general theory of relativity to make calculations, like to make corrections to the calculations. For example, for our GPS
Okay.
satellites, diba, that we
Oo.
use directions to get to, like for
Mhm.
example, we got here, we used Waze.
Mhm.
So because those satellites are already in orbit,
Mhm.
their gravity is different from the gravity here on Earth,
Yes.
near the surface of the Earth, and so there are what we call relativistic corrections
Yes.
in the time. In fact, time is slower if you are in a stronger gravitational field, so you have to correct for that. And we do that, and it works explicitly. It has also been tested in the solar system scales,
Mhm.
and of course, to explain pulsars, black holes, their gravity is very strong. But in the cosmic scales, there have been few, or actually not a lot of tests of gravity. So our paper, the proposal was, it's a proof of concept that will actually test gravity on cosmological scales. So these are the scales between galaxies, and that's what we did, and we published the result as a proof of concept that you can actually test gravity on cosmological scales. And with our results, using around 70,000 galaxies in a slow digital sky survey,
Mhm.
um,
70,000?
70,000 galaxies in our sample. And that's actually the reason why we were able to do this, because of the availability of this data.
Ah, okay.
We actually measured a quantity um, that's called E sub g, and that quantity um, is predicted to be a certain value by Einstein's theory of general relativity, around zero point 0.4. And then in other alternate theories, the value could be lower or higher. It could be different.
how does it affect kung higher or lower?
So basically, it's the prediction of the theory. So in the other theories, for example, the the ratio of two different um, there are two different gravitational effects. One is called clustering, which is how clumped together the galaxies are,
Okay.
and you can measure that from the 70,000 galaxies. And then there's another gravitational effect that's called lensing, gravitational lensing.
Lensing parang sa black hole, parang
Oo.
sa Interstellar, di ba?
Yes, exactly.
Yeah.
Exactly. That light is bent
Yeah.
by gravity, just like our glasses bend light.
Is it
So
is it
it acts like a
observable?
lens. Yes, yes.
May ganun talaga na
Yes,
nakikita kapag,
yes. We
wow.
observe. So the spectacular examples of these are what are called strong lensing regime because it's very strong. So basically, the whole galaxy is squished into arcs. So what we see, the images we see are arcs, but they are basically galaxies in the background that are lensed by a foreground galaxy or galaxy cluster, and so we see the arcs.
Okay, can you see if you can find images of that lens?
Oh, sure, yeah.
May mga
There are Hubble images, strong
just
lensing, and then we can show it in the video.
pag may narinig ka na just mag-Google ka lang para may
Gravitational lens.
Oh, in real time, gravitational lens.
lensing.
Yes. So,
Tapos,
yeah, exactly. So that's almost a full circle yung arc niya. So that's actually a galaxy in the in the background. But you see, it has been squished to an arc. But it's just an image, so it just appears like an arc. Oh yeah, that's almost a complete arc.
Wow. So
By this
basically what's
foreground,
that yung parang sun sa
elliptical
gitna,
galaxy.
ano siya?
It's actually another galaxy that's closer to us. It's an elliptical galaxy that is serving as the lens. So the gravity of the elliptical galaxy, that red galaxy, is causing the image from that's a good illustration because then here you see the galaxy at the back. The light
Can you go for
that
the
we
other
see
again?
here on Earth will be lensed.
So basically that star in the middle,
Yeah,
it's a galaxy pala. So meron pang galaxy sa likod. Yung mga light na nakapalibot doon is light from the galaxy behind.
Exactly.
Oh.
And it's actually also I think magnified by the lensing effect.
Wow.
So this is actually one of the ways we can see faraway galaxies because the most far away galaxies, right? Because they just happen to be lensed by galaxies that are near to us.
So those are
They're like magnified.
Yeah, so these are direct this is ang tawag dito, parang demonstration to ng gravity.
Oh yes,
Einstein's gravity.
Yeah, in fact, Einstein's theory of gravity was proven first, confirmed by the gravitational lensing effect of a star by the sun.
Yeah.
So during the solar eclipse, and then Editon had this. So actually, Newton's theory of gravity also predicts the lensing. So the difference is just a factor of 1/2. So the actual angle of the deflection, now I don't remember which way it goes. If it's twice, I think it's 1/2 for the general relativity. It's half as small as the prediction of Newton's theory.
Okay.
And because they predicted that it was half na what was expected, or in a way, or another way putting it is it was consistent with what general relativity predicts, then that's how we confirm theories, right? We have different theories and they have different predictions for certain phenomena. For many phenomena, they would have the same prediction. Like Newton's theory still holds in the regime of relatively weak gravitational fields, like for the Earth and for the solar system.
Mhm.
So, but there are regimes where they would be different, or there are certain phenomena observations that they would be different. And then scientists would want to make those observations and compare it with the predictions. And then the observation, which observation would be consistent with the prediction, would tell you which theory is more correct.
Wow.
And so that's actually the same idea with our measurement, with the paper. Because basically, the idea is there are these different theories of gravity, and they have different predictions for this E sub G
Okay.
method, which is what I'm explaining is the E sub G is actually a ratio of the clustering and the lensing effect of gravity.
Okay.
So the different theories have different ratios, could have different ratios. This was your question, right? What does it mean? So basically, it comes out of the theory, what this ratio is. And then the measurement is directly measured from the galaxies, astronomical observations. And then you can compare if they are consistent with the theory's predictions.
Wow.
And what we found is that they were consistent with the Einstein's general theory of relativity.
So you
So
were
it's a confirmation. Yes, yes.
So you were testing then with Newton's yun ba? Was
Well,
it?
not anymore with Newtons because we know now that general relativity is more precise or more correct. Of course, we can go into the philosophy of science of what does it mean that the theory is more correct. But at least we know that in this regime, Einstein's theory is our best theory.
Yeah.
But we are also comparing with alternate theories of gravity. But the caveat there is that these alternate theories of gravity are still also being developed. And so it's not even clear what their predictions are. That's how new they are. Although some of them, the simplest ones are called F of R theories, which essentially generalize Einstein's theory of general relativity. So, like in Einstein's equations, there's a quantity that's called R. It's actually yes, it's called the Ricci constant. And so in Einstein's equations, it appears as R,
Mhm.
but you can come up with another theory where it's a general function of R. So that's why it's called F of R.
Oh.
So F of R, the function like F of X, di ba? If you still remember
Yeah.
high school
Okay.
algebra ba yan?
I'm just trying to keep
F
up.
of X equals x squared plus 2x plus 3, right? You can have polynomials,
Mhm.
so it can be x to some power.
Mhm.
And so that would change the predictions of the theory. And for some regimes, the idea, of course, is they want to find a universe that accelerates because that's what we observe. So the goal of these theories, of the theorists, is to look for a theory that would explain all the observations and then make more predictions that can be validated by new observations.
Okay.
And then observational cosmologists naman, their goal is to look for these signatures and actually measure them using the best available astronomical data.
How did we confirm that the universe is actually expanding and accelerating pala? Paano nalaman?
And these, so the Nobel Prize winning work is
Mhm.
actually based on supernova observations. So supernovae are very bright, the brightest objects that we can find. So you can also see them farther out. So the idea is you need to see the farther out because when you see farther out, when we look at di ba, space,
Mhm.
we look out in space, we're actually looking backward in time,
Yeah.
right? Because it takes time for light to reach us.
Yes.
Because, it's actually astonishing, but light travels very, very fast, but it has a finite speed, right? It's around 300,000 kilometers per second. So, for example, this light over here would reach our eyes in 1 nanosecond. So for us, it doesn't matter, right? But let's say 1 nanosecond.
Okay.
And in fact, what the me you're seeing is not me now, right? But 1 nanosecond ago, because it takes time to reflect to your eyes. And then as you go to astronomical distances, that becomes so the moon is like half a second to get to us, and then the sun is 8 minutes away, or eight light minutes away.
So pag nag-shutdown yung sun, 8 minutes bago mamatay.
Exactly. 8 minutes before we know, we even know. And even gravitationally, gravity also travels at light speed.
Yeah.
Actually, everything has that limit of we cannot travel faster. Signals cannot travel faster than the speed of light. But again, that's based on Einstein's theory of relativity. And so far, we have not seen any evidence that would be broken, right? There have been claims, but they always did. So anyway, now if we go to stars, then it's the stars that we see at night would be thousands, hundreds to thousands of light years away. So we would see them as they were hundreds of years ago, thousands of years ago. And then finally, if you go to galaxies, then it could be millions to billions of light years away from us. And so when we study the galaxies, like the 70,000 galaxies that I talked about, we would actually be studying an earlier epoch of the universe. Especially if we go, actually what we studied are actually relatively nearby, but we could go, especially using supernovae or these lens galaxies, then we could go even billions of years ago. And so, and then as you sample, like as you observe different galaxies that are different distances, you can actually trace the but in this case, the expansion of this universe. But you can also actually see how galaxies evolve over time, because you are seeing them at this time, at a different time in the universe's past.
Okay.
So one analogy, it's just an analogy, but it's like archaeology. So it's been called like galactic archaeology, right? Because
Galactic archaeology.
in archaeology naman, when you dig down deep in the ground, right, as you go deeper, you would see species fossils from an earlier time on Earth.
Yeah.
But that's because they are, ano ba?
Yeah.
They were, parang you just, you keep piling up, right? Here, it's really because of the speed of light. And it's, and it's lucky, right? Because that's just so happened to be the way we can study cosmology. Because we can observe the past from where we are if we look out at faraway things, galaxies and supernovae. Of course, there's more detail. There's always more detail because these are always technical. But basically, these supernovae, we can also we know their luminosities, and so we can tell their distance. And then from the red shifts, yung shifts of in the spectrum of the light that we observe, we know how their velocities relative to us, which is like naman the analogy. And this is really the same, the Doppler shift. In the ambulance, right? In the ambulance, when the ambulance is moving towards you, the pitch of the siren becomes higher, and as it moves towards you, pababa naman, yes, and then pababa naman, yes. So the pitch depends on the velocity of the moving of the source of the sound. In this case, the ambulance. relative to you.
Mhm.
So you can tell from the pitch if it is moving towards you or moving away from you.
Ah, okay.
And in the same way, light also experiences the same thing. It's a wave, just like sound. But light, what changes is the frequency, and that changes as in our eyes. We see that as color. So if it's something is moving towards you, the frequency would be higher, just like the frequency of sound is higher. We hear it as a high pitch. For light, it moves towards the blue. So the spectrum is red to blue, um, just like in the rainbow, right? Red, orange, yellow, green, blue, violet.
Okay, so
So that's from low frequency to higher frequency,
blue is high frequency.
relative to red. Yes. And then if you go to even higher frequency, that becomes ultraviolet. It's called ultraviolet light, and then we cannot see it anymore. Right? It's beyond the visible spectrum.
Got
But
it.
it's what gives you suntans and skin skin cancer.
Yeah.
You're not protected from UV rays. So anyway, when the star or the supernova or the galaxy is moving away from you, um, then the light would be shifted. The frequency of the light would be shifted um, lower or towards the red. So we call that redshift. That's what we call redshift.
Okay.
And redshifts actually measure the distance. We astrophysicists and cosmologists use redshifts to measure distances because of the expansion of the universe. So the higher the redshift, the farther away it is from us, the faster it's moving away from us
Mhm.
because of the expansion. Um, so using the redshifts and the distances actually would, because it's not, well, that's what we found, it's not constant, but you can trace how fast the universe has been expanding at different times by comparing the redshifts and the distances to faraway objects, in this case, supernovae. And what, and then, and then actually you sort of fit those observations with different scenarios from general theory of relativity, theory that we have, and it won't fit unless you add this dark energy component, which makes the universe accelerate.
Yeah.
And it's only happening now. So the way it fits, the best model that fits, so basically we are living in the epoch or this is the age where we say the dark energy is starting to dominate over the matter, and so um, the expansion is starting to accelerate. It's just starting to accelerate. And if we believe that this model is will hold, then it will continue to accelerate to the future, um, and that will be the fate of the universe.
Wow.
So before, the thought was that it would eventually slow down, or could even reverse itself and collapse.
Mhm.
So that's
So
because
babalik siya, di
right,
ba?
right, there's a maximum, and then it will collapse. So that's what we call the big crunch.
Okay.
But now that's been ruled out because
Oh, wow.
it's
Because of you guys.
no,
no?
yeah, because of the acceleration, right? So it's not slowing down. So therefore it cannot go back.
I see.
So now the most possible scenarios, if this holds, is that it will keep expanding. And it depends on how strong the dark energy is. It depends on the model, and yet. But if it's the strong kind, then it will eventually even accelerate faster and faster, and until all the fabric of space-time rips apart. So this has been called the Big Rip scenario.
What?
How
would
not
you-
even know what the fabric of space-time is, but whatever it is.
How would you visualize that happening? How would space-time rip?
Yeah, no, but it's actually very science fiction
Oo nga eh.
regime or area. But um, well, because essentially, when they play out this scenario, it's like um, of course, objects will rip themselves apart, and then the atoms that make up those objects would also rip apart, right? Until you get to the very end, which we don't know what it is, but if what is left is space, time, whatever it is,
Oh.
it itself will also rip apart. I mean,
Oh,
that's the picture.
that's there's a lot of things that we're
the end of the universe.
hindi pa rin talaga alam eh, di
No,
ba?
definitely, definitely.
Like yung dark matter from what I know, it's just parang okay, hindi natin alam to, dark matter.
That's why it's also called dark, right?
Oo
So
nga
now we
eh,
have
di ba?
two big components of the content, energy content of the universe that in fact dominates the universe, and we don't know much about them. So that's the dark energy, which is around 3/4 of the energy content of the universe, given these observations. And then the dark matter, which is around 5%. Sorry, 25%. So actually 20, how do you say that? So I think it's like, yeah. So it's not exactly like 72% and then like 5%. And so you are left with some 3% or 2% or less than 5% of the normal matter that
Of
we are.
the actual things that we see in the universe.
Right, right,
Diba?
exactly. And that make us up. So the periodic table of elements, hydrogen, helium,
And that's so
carbon,
crazy.
and
Diba? If you think about how crazy big yung mga objects outside, diba?
Right.
Tapos they're just
and then it's only a small fraction of what is the most interesting part, at least as far as we're concerned. But the evidence for the dark matter is incontrovertible because, of course, there are still scientists or there are still alternate theories that try to that say that dark matter is not really real, but yeah, and they also try to explain the effects of dark matter through alternate theories of gravity, but in smaller scales because we see these dark matter effects um, in galactic scales. So they, it's harder to argue that. But basically, we see when we measure many things like velocities, lensing, for example, the effect of the gravity is smaller. I mean, it's much larger than if it was only due to the stars or the things that we see. So
okay, you say that
we can
again?
the effect of
Gravity.
the gravitational effect that we see in the lensing and in the velocities, right, it depend on the mass of the galaxy, for example. So you calculate that mass, and it turns out to be like 10 times bigger than what you would expect from just the stars. Because we know what we would expect from the stars because we can see the light, and then we can sort of estimate how much mass there is.
Talaga? Ganun, that's how you find out the mass of a star. Because of the light, you observe the light.
Well, that's one way to estimate it, right? But the problem is, when you actually compare that, you are 1/10 off. You're missing mass. You're missing a lot of mass. And that's what we call the dark matter. The dark matter is what is that mass there that you cannot see, but is causing these gravitational effects. So dark matter is only effects, at least, I mean, by definition, is gravitational.
May tanong ako.
Mhm.
Tayo as individuals, any kind of matter,
Mhm.
may dark matter ba tayong kasama? Ganun ba yun?
Not us, but there are dark matter particles around us right now. I mean, that's the idea. That's if the dark matter particle is like is a fundamental particle, so it's as um, ano ba? It's an elementary particle, like an action or a So there's dark matter all around us, but it doesn't interact um, electromagnetically. So it just we just pass through it, and so yes, that's the idea. So there are experiments that are deep underground that are trying to detect the dark matter particle. And that would, and if they do that, then they would now get evidence that this dark matter particle exists. And in fact, they can characterize what it is.
Parang
And then it would be
parang nakahuli na yata sila eh. Nakahuli na ba sila?
the dark matter particle. Wala pa. If they do that, that's also a Nobel Prize.
Oh my God.
If they find that. The problem is that they've been trying for I think nearly a decade, and they're not getting. They haven't found anything, but they have of course they have improved the limits. So if it was this, for example, this one, if it had these properties, they would have had detected it already. So they have ruled out a lot of the parameter space where theorists are saying this dark matter particle could be.
Okay. So, ini-eliminate na nila.
Na-eliminate na nila because they have been improving their experiments, and they've been creating more sensitive instruments, and they've been running the tests longer, etc., etc. Diba? So now, it's either they say they find it within the next few years or maybe a decade, depending on how optimistic you are, or you have to now start entertaining other possibilities because where the theories say they are, or where it could be found, it wasn't found.
Is dark matter part of the string theory? Parang dun ba siya? Hindi.
Still under high energy physics.
Okay.
So high energy physics.
Hindi siya quantum. Hindi siya quantum physics.
Well, it is quantum physics, pero not strings. Strings are more, ano ba?
It's weird.
Speculative, yeah. String theory has no evidence.
Yeah.
Pero all these quantum field theory, particle physics, so these particles are being observed and created in these accelerators. So in this whole, I'm not that familiar with that because that's not my field, but basically in this theory, there could be these different particles and elementary particles, and there are so-called dark matter candidates.
Like madami ba?
Yes, and then there's a whole family in parameter space, and that's why the experimenters are just ruling out parts of this parameter space.
Bakit nila hinahanap tong dark matter na to? What could be the potential use of this of harnessing? Are we planning to harness it or just understand it right now?
No, I mean at these levels of questions, like even why are you trying to prove Einstein's theory of generality? It's not for practical use, right? It's really driven by curiosity, because it's like a detective story, right? So, for example, you found that dark energy. I mean, you found that the universe was accelerating, and so now you need to explain why. And then you find this missing mass, and you call it the dark matter. Now we want to find out what it is. So that's the goal, is to figure it out.
I see. So maybe pag when the time comes that kung aabot tayo doon, that we could go out of the Earth and go to mag-interstellar travel tayo.
Yeah, definitely.
Doon magagamit siya, di ba?
Definitely, you could argue that a lot of the basic sciences, right, or a lot of the discoveries that were made decades ago or hundreds of years ago, were not made for practical use, but just to figure things out. And eventually they were able to use. And in fact, all of the technology, of course, that we use today, it's not possible if we did not understand. Well, actually, it depends, case to case, really, because sometimes it's really the practical application the technology that comes first, the invention that comes first, and then it takes time to understand why it works.
Oo nga.
But it's still uh, um, eventually explained by science or a theory, right?
I remember the story nung kay Michael Faraday yata yun. When he invented the first motor, parang edi nakita niya he figured out how to make the thing to move around continuously eh. Dati kasi parang titigil. Sa kanya napatuloy-tuloy niya. Tapos nung when he presented that invention, sabi dong whoever that guy in charge was, sabi, so ano gagawin natin dyan? Di ba? Sabi, si Michael Faraday, yung sagot niya parang, I don't know, hindi ko rin alam. Pero ang alam ko, one day you're gonna tax it. Di ba? One day you're gonna tax it. So, di ba? And now, it jump-started the Industrial Revolution. Lahat ng mga motor, engines are based on that design, di ba?
Definitely. Although you can argue that some people argue also that we have achieved this stage where we've gone so far from the everyday world, at least in physics, right? And in cosmology, that we have gone far beyond what would be practical, at least for our generation. But of course, if you're really thinking far, right? If you're thinking about warp drives and all of that, then of course you need to push the boundaries of what we know now. But in comparison, let's say biology now is actually in the stage where, so they say the golden age of physics is done, and now it's the golden age of biology. Because now the discoveries in biology will actually make the biggest impact on our society. Genes and understanding.
Pwede ka nang mag-engineer ng baby, no? To your exact specifications.
Yes, one of the
Grabe.
so, and also, yeah, a lot of a lot of ethical issues that come with it. But basically, it's because the knowledge and the technology is ripe for these advances that could impact us now. Just to contrast it with, let's say, dark matter particle discovery would not impact us anytime soon.
Yeah.
Just to be
Parang yung
upfront
like
about it.
the technology, yung basis ng internet technology has been figured out in the 30s yata. Tapos ngayon lang natin nagagamit to its full potential.
Right, because the technology has to also be there.
So I would like to ask you naman, how did your journey in science start? Paano ka naging curious? Have you always been
I think from I don't remember much, but even as a child, diba, I was fascinated by these questions, and then when I was growing up, it was still like we had encyclopedias, so wala pang internet. Pero when I was in grade school, that was the first Encarta CD. I still remember that.
Okay.
So yun yung
may CD.
yun yung age ko. I got the CD. And then like I guess mga programs sa PC na let's see the planets, ganun. So pre-internet age. But I also tell a story na when I asked these questions, I was lucky because my parents, my mom, in particular, they encouraged asking questions and finding answers. So for example, let's look for it in a book, or let's buy a book that's for astronomy to answer these questions. And so na-encourage naman. Although at that point, I had no idea that you could be a scientist. So it's not part of my, uh, di ba, when they ask you, what would you be when you grow up?
Mhm.
Um, so I had answers like, I wanted to be an architect.
Mhm.
Kasi may pinsan ako na architecture noon, and parang kung ginagawa niya.
Mhm.
I wanted to be a lawyer, with a family lawyer na also parang expected siya, ganyan, diba? And then eventually business, because my parents were in business, were Chinese, Filipino Chinese, businessmen. Only in high school, so yun nga, in elementary, may tinda ako sa science, and so ako yung nagre-represent sa science quiz bees, or parang quiz bees, ganyan. And then I learned about the Philippine Science High School, which is a school nga daw for science, di ba? So parang, wow, I want to enroll there. So I told my mom, and then they were not familiar with it kasi we didn't know anyone who went there. But she did research ako, tinawagan niya, ganyan. And then so I actually applied.
Pisay saan?
Pisay in Diliman.
Diliman. Okay.
And then I got in, and that's where I was more exposed to science as a career. And so eventually, that became my goal that I wanted to be a scientist. And there also, I decided I want to. My favorite science subject was physics, so I decided that I would go into a physics degree in college, and then from there, and then also there you learn that it doesn't stop in college because to become a scientist you need to specialize in graduate school. So from there I also aimed at doing a PhD, and eventually did my PhD in astrophysics at Princeton. Um, and yeah, that's my sort of the journey from grade school to
Princeton.
PhD. Yeah.
So you're done with your PhD, no? Okay.
In 2011, so it's been 7 years.
So when you did the your paper, you were still studying?
Part of my PhD.
Wow. So how were you actually observing these galaxies from a telescope?
So the Sloan Digital Sky Survey is like automated survey. Of course, there are still people, but basically it's programmed to scan the sky every night. And so that was one of actually the revolutions. This so-called big data revolutions in the field, in astronomy in particular, is now you don't have to observe all the galaxies yourself. So before that, you have to observe, and then you can maybe do 20 galaxies, 50 galaxies, 100 galaxies, right? But now, because of the survey, they were able to do like hundreds of thousands, or a million, a couple of millions of galaxies over a period of 5 years.
Wow.
And so now all of this data is processed also. Of course, there's a team that processes it. And then, as a researcher, you can just now download the data. And in fact, you can do your own processing, and that's what we did. But for my thesis, I also did what we call follow-up observations. So on those galaxies that were part of the survey, we targeted them, and then I actually did my own observations for 99 galaxies. This is in my thesis, my paper there. I ended up getting 99 galaxies, doing a different observation called slit spectroscopy.
What?
So that's
Say
why
that again?
I had to do. That's why I had to do more observations. So it's called slit spectroscopy. So there's a slit. That's why it's slit. Like there's a slit, like a rectangular hole.
Okay.
That you have to position near the diameter of the galaxy. And then spectroscopy you get the spectrum, or you break down the light into frequencies. Exactly as we talked about earlier, to get the redshifts. And with the redshifts, you can actually get the velocity curve or rotation curve of the galaxy.
Ang galing, no?
But then the whole thing there also is that I didn't have to be in the telescope because the telescope is now can be remotely, we call it remote observing. So I was at Princeton, the telescope was at New Mexico, and of course I have to stay up at night because it's at night. Yeah,
Is that it?
something like that. Yes.
Okay.
Um, these are the different wavelengths.
Nakita ko yun, have you seen the
Prism.
Neil deGrasse Tyson's Cosmos series?
Ah,
Diba, parang he talked about this parang tapos when it was discovered, so yung light spectrum, di ba kay ano yun kay Newton siya yun.
the prism.
Pero he wasn't able to do the next step. Tapos somebody else did it, I forgot the name. Tapos doon niya nalaman yung meron pa palang yung mga lines, diba?
Absorption lines in the spectrum.
Tapos ang fascinating is through these lines, you can tell the composition of the star and the planet.
That's right.
What? Diba?
Like,
Paano yun, diba? It's mind-boggling.
yes,
It's
yes.
mind-boggling.
Because there are signatures of the different atoms.
Oo nga
That we
Depending sa
and then,
color.
And then it's all shifted. So yun nga, yung shift nung lines, yung absorption lines, exactly na yun, are what we can use to tell the velocity, the redshift of that star.
You can also tell the velocity, the speed.
Yes, because of the shift in the lines.
Ah.
Because you can compare it with, you know what it should, where it should be
Mhm.
here on Earth, and then you find it somewhere else
Mhm.
because it's redshifted, and then the amount of the shift tells you how fast it's moving away and towards you.
Oh my God.
So that's what we measured using slit spectroscopy to get the rotation curves of these galaxies to study the dark matter in them. Because you can compare it with the light, and then you say, again, we actually detect the dark matter through the gravitational effect.
Oh my God. Thank God for smart people like you and and others who came before you guys. Kasi if when I see that kind of yung light na yun, ang ganda. Ang ganda dun lang ako.
It's also
Oo nga,
aesthetic
diba?
communication,
Diba? Ang ganda diba?
Galaxies
Tapos,
turn out to be very aesthetic pleasing.
from what I saw dun sa show dun sa Cosmos, dun sa Bawang Cosmos. So, parang they were testing the light of the sun. Tapos he used magnifying glass. Tapos lumabas, kaya niya na-discover yung infrared. Kasi meron siyang mga test na may mga paper na magre-react sa light.
Okay.
Tapos dun sa isang paper, wala naman siyang nakikitang light kasi parang blue yung
split siya.
tapos meron sa dulo na nag-react din pero wala siyang nakikitang light doon.
Oo,
Kaya
so
ginawa
that's
niya,
infrared.
yun yung
Yun naman
infrared.
is the frequency below red.
Oo, diba?
Right. Kaya siya infrared. Sa violet naman, it's ultraviolet because
Oo nga.
we just explain because it's next to what we can see, right?
Oo nga.
But then it goes all the way, right? So microwaves, radio waves, and then that's below red.
So astrophysics is basically without yung mga ginawa nga ni Newton na to. Kasi, ewan ko correct me if I'm wrong. Whoever,
It builds up on what we looked for.
from the lights. Kasi that's what, you can't go to that
Exactly,
place,
no,
diba?
exactly. Astronomy is like very special because we cannot do experiments because you cannot have a galaxy in a lab. And all we can observe are photons, which are these, particles of light that have traveled billions or millions of years, and that we capture in our telescopes. So the instrument is a telescope.
Yeah.
That has a mirror. Again, it's Newton, it's Galileo, right? The first telescope used to observe astronomical phenomenon. Which is a light, is a mirror to capture the light, and then lenses to direct the light, and then camera to measure the light. And now, of course, technology is from a film to digital, as we saw in the consumer cameras as well, right? So CCD chips in our digital cameras, we just have big ass versions of that in the telescopes.
Wow. Grabe, no? Pero, di ba, it's fascinating talaga that people figured these things out. Kasi parang, I don't know, it takes a special kind of mind to go beyond what you see. Na, parang, okay, naging rainbow, di ba? Yung mga scientists would ask, bakit naging rainbow? Di ba? Di ba? So, and
You ask different questions.
di ba?
Or you're looking for an explanation. And it turns out that the explanations are mathematical. There's no one, I mean, it couldn't have, I mean, you could imagine that it wasn't that way, right? It could have been, I don't know, something else. But it turned out to be, turned out that we could explain the world around us using mathematical equations. And that's what scientists do, study, and it's been successful.
And a lot of theories, like especially Einstein's, you can't really. He made predictions based on mathematical
Formulas.
discoveries, but mathematical lang na mathematically it says the black holes are possible, so they must be there, di ba? And mathematically yung lensing nga, di ba?
Definitely. So math, in this case, is the language of science.
Mm.
But math, of course, is another. I mean, math can describe other universes in a way, like, or other laws that we don't see in our universe. But the physicists like Einstein figured out which mathematical formulation would be consistent, or I don't know if it's consistent, but he just imagined that would describe gravity, for example. And that's his genius.
Okay. So from what I read and watched on shows, he was just thought experimenting eh.
Relativity was really driven by thought experiment. Amazing, yeah. And so,
Can you tell us about
general relativity in particular.
parang that's something that a lot of people parang hindi are missing out there. But parang the the idea that you can visualize things and maybe come up with an answer to hindi lang about basically about any problem, di ba?
About anything.
Oo, di ba? May mga tropa kong nag-aaway. Pwede mong gamitin yan, di ba?
Imagination and trying things out, or what ifs, what if scenarios.
Based on what you know, di ba? May mga syempre parang kasi ganito siya. And
like logical steps. Logical steps will bring you to a conclusion which you would have not have intuited from the start.
Yeah.
But for example, science would follow the trail, follow the trail, right, to its conclusion.
Yeah.
And because when you Sherlock Holmes, right, because this is true, and this is true, and this is true, this is true, even end up with something counterintuitive, it's actually solid because you follow this systematic way of thinking about it.
So that's the scientific method, di ba?
In a way, yeah.
Yun yung isang thing about I think the problem sa science, sa sailing science in the Philippines is parang when we studied about the science method in school, parang it was hindi ko siya naintindihan what it really meant. From what I got during that time was I need to memorize these steps and then write it down. Write down the steps during the examination and then pass ka na, di ba? But if you I don't think you can be a scientist if you don't fully understand the scientific method, eh.
Mm,
Diba?
no, definitely. And in fact, it's part of everyone's ano ba? Should be part of everyone's education, right? Because it's such a big part of our world and our history. But you're right. I think when it's a commentary on science education,
Mm-hmm.
that we focus on facts and interpretation rather than the process of science.
Just para lang sa mga nakikinig, let's describe what the scientific method is.
Oh yeah, I have a perfect. Actually, I remember my grade school lesson on scientific
Mhm.
method, and because we actually did an experiment
Mhm.
with the mango seeds.
Uh,
So you have two mango plants. They have the same pot. They have the same soil,
mhm.
and then the seeds presumably also come from the same
Mhm.
source. And then so you plant them, but then you put one under the next to the window so it gets sun,
Mhm.
and you put one inside the cabinet
Wow.
so it's dark, right?
Mhm.
And then you measure how
Growth.
the growth, the height of the mango plant,
Mhm.
right? You actually take a ruler, one of those
Mhm.
plastic rulers, and then you do that every day. And then you log it, right?
Mhm.
You compare the measurements,
Mhm.
and then you say that um, you actually find that the plants that were exposed to the sun grew um, faster or more than the plants that are in the cabinet. And then, of course, yung thing about the exam is, of course, you call this control variables, right? And the experimental variable is the exposure to the sun.
Mhm.
Because it's the only, so basically you keep everything the same, the
Mhm.
different variables,
Mhm.
except for one,
Mhm.
and then you
So, meaning you water it at the same amount, di
oh
ba?
yeah, everything should be the
Tapos,
same. The soil is the
oo.
same, the seeds are the same, yeah, you water it the same. Um, and then when you find the difference, you can say that it's because of the difference in the exposure of
Sunlight.
sunlight, right? So that's like um, how you test a hypothesis.
Mhm.
So in this case, the hypothesis is that exposure to sun would make is important for the plants.
Mhm.
And then you actually design an experiment where yeah, you control everything except for the sunlight. You change the sunlight, the amount of sunlight, and then so you do an experiment. So you start with a hypothesis. Ito yung scientific method.
Mhm.
Diba? You start with the hypothesis.
Mhm.
You design an experiment to test that hypothesis,
Mhm.
and then you do measurements.
Mhm.
That's where data comes in because that's data. When you do the measurements, the heights,
Mhm.
and then you analyze the data. That's data science.
Uh-huh.
You now call it that way, and then you make conclusions. And the conclusion is that you either confirm your hypothesis
Mhm.
or 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 don't. So if there's no difference, then you say your hypothesis is wrong because what you actually observe, what you actually measure is that it doesn't make a difference. But if you observe a difference, then you can conclude that the exposure to sunlight um, affects the growth of the plant.
Diba? Parang, how how unfortunate is it that this is not ano na parang communicated properly? What do you think is the
Yeah, it's
problem?
hard to yeah, it's hard to assess the impact. But of course, we can do better at many things, diba? Many things
Kasi even
in education, but science is one of the big big ones. Because I think it affects your mindset, your thinking about the world, um, not just for science, not just to become a scientist, right? But as an educated citizen of the world,
Yes.
how you critically think, diba? How you, for example, you look for evidence, or why do we believe what we believe, for example. And so
The thought
it's
process.
not, yeah, it's not, it's yeah, I think it's not too far stretched to go to fake news, for example,
Yeah.
or um, um, yeah, or um, critical thinking, because that's what science teaches you, right? Teaches you to
Test
to
ideas
to test the ideas
before
to
believing.
before believing, right?
Diba?
A certain and a healthy dose of skepticism. Um, I think couldn't hurt. Yeah, couldn't hurt.
Grabe, no? Parang, kasi even parang, siguro, it took me a while na parang, yun pala yun. Yun pala yung, it's more than just, um, memorizing, a set of words, diba? A few sentences. And it's very profound eh. The scientific method, it's parang, it's life changing if you can follow it. I think it's a
And in fact,
philosophy.
yeah, and in fact, you can do it with your own life, right?
Oh,
For example, if you want to lose weight, or if you want to get better at your job, or I mean, um, then you have a hypothesis, right?
yes.
Okay, maybe it's the milk tea. That's the reason why I'm not losing weight, right? And so you just try it, you do an experiment for a month, you don't drink milk tea, and you measure your weight. And you can actually plot it, right? In Excel, you can plot it, and you can see the effect. And I'm sure, I mean, it would be better um,
Than not knowing
than not doing it. Yes.
So you.
Of course, it's not, if science could solve the weight loss problem, then it would have been solved. No, I mean it's more psychology and all of that.
Oo nga.
But I'm just saying that it's just to also put it in perspective. It's just one way of thinking about the world, but it's a very powerful way of thinking about the world. And if you have like this tool set, right? You also have the artist tool set, creative tool set. You also have like, of course, your um, yeah. So there are many ways of thinking about the world, but the scientific way is, in fact, one of the more powerful ones and one of the more successful ones. Um, that is, I would say, a heritage. It's like pinamana sa atin of all the thinkers and all the scientists that have come before us. So we're lucky in this modern world to have that, right? If you were born 1,000 years ago, it would have been part of our civilization's knowledge, but today is so. Um, and everyone is, of course, welcome and invited to partake, and even maybe to join the. Of course, this is a recruitment thing, right? We need more people
Yes.
to keep it going because yeah, it's actually dangerous times, and
Yes, it is.
if you don't believe in climate change, for example, then even if all the science points to
We're fucked. But, well, I remember what Neil deGrasse Tyson says. Parang it's for ordinary people. Parang okay, you believe what you want, pero don't get into the business of handling, of being the one to decide for
to make
everybody.
decisions, right?
Diba?
To make decisions.
Grabe.
This is the best yeah, the best tool set in a way that we have, right? And if we don't rely on it, if we don't use it, then it's our fault. It's like it's humanity's. But maybe that's our.
Yeah, yeah.
Maybe that's well. That would make a difference. I mean, one way to put it is that would make a difference between succeeding as a civilization and not. And maybe there are millions of other civilizations. It's just
Before we can go to the warp drives.
right.
Diba? We gotta
It's
get
like
through
this-
these first.
yeah, it's like this test, right? Do you make it or not? If not, then you're dead.
Oo nga eh. Hindi tayo aabot dun sa ano. Ay, mag-hide lang tayo dun sa... That's exactly what Marivi, our good friend Marivi said. That we need to encourage more people regardless of gender to get into the sciences. There's also... I read about... well, I was looking up things about you when I invited you, diba? Parang what I found out is that you left the US to basically you came back.
Came back, yeah.
You came back because you want to be part of of what do you call that?
Building the
Awareness.
contributing here, yeah.
Yeah.
Contributing
So can you
here
tell us about that?
for
What kind?
the next generation of scientists. But also because I just missed home, right? I missed home. I grew up here. Um, and then I went abroad to pursue graduate school, maybe to get training as a scientist. Um, and then well, I call it an early midlife crisis. I was 26, but um, basically I already asked the questions of what is it all for, right?
Okay.
And that led me to seriously consider coming back early, maybe earlier than earlier than others, because others would wait to retire and then come back, right? Because that's what the Filipino diaspora does, right? But for me, I think that question came earlier. Um, yeah, most people, right? They work there, they spend their productive professional life there. Scientists also. And then when the time comes, then they ask, "Diba, what is it all for?" And then they want to contribute. And they do, and they do, and and I'm very glad that they do. No? But for me, it's just like, if I'll do that anyway in 30 years, why don't I do it now? And then spend my productive professional life here. At least that was the idea. And actually, I have to say that it's turning out well. Not well, more interesting in fact than what I imagined, because I imagined just staying in the academy, but I ended up having more opportunities and experiences outside the academy. So now I work also consulting for industry, and then doing this outreach. And now even on TV with the Knowledge Channel, hosting a gig to spread science and to show that science is fun um, not memorization of facts.
Tell us about your show in the Knowledge Channel.
Yeah, it's a cool concept. It's called Science Says. And in every episode, there are short episodes, like 3-minute episodes. In every episode, we do an experiment. These are like simple experiments that anyone can do at home and that students can do in the classroom. So, for example, we have an experiment where we have what do I talk about?
Ano yung mga topics na kina-cover dun sa show?
So we have phosphorescence
Wow, what's that?
concept. So it's like glow in the dark. Yeah.
Yeah.
It's a glow in the dark paint, and then we actually do the experiment, and then we explain what phosphorescence is. Nag-iipon ng ilaw yung mga paint. So and then there's a question kung anong mangyayari. So before we do the experiment, we say, ano kaya ang mangyayari? And then letter A.
Okay.
B, ito, C, ito. So iba-ibang scenarios. And then you're asked to think about it. And then you actually do the experiment, and then you see, ito na yung mangyayari. And then we explain. And then, of course, hopefully that triggers enough curiosity for the viewer or the student to explore more on his or her own.
Is it already showing?
Yeah, I just started showing at certain times in Knowledge Channel, like in between shows. I think it's showing 3 times. I don't remember now. It's like 9:30, 4:30, 7:30, something like this.
What's the title again? But maybe we can find an image
And
of
we
that.
can actually show the link. Sorry. And then we'll upload to YouTube also.
Sciences, ano?
Sciences.
Sciences.
Yeah.
Sabi ng science.
Yes.
Okay.
Sciences. Reina, lagay mo yung Reina Reyes.
Knowledge Channel. Sorry.
Oh?
Yeah.
Oh, yeah, okay.
Yeah. But that's it. You saw yung clip na yan, teaser. Yeah.
Okay. Sige, iyan natin.
Mm.
Whoa!
Yeah, that's capillary action. That's the phosphorescence.
Inaano lang. Wow, okay.
Yeah, so they'll be uploading episodes also to YouTube, in the Knowledge Channel YouTube channel, I
Okay.
suppose.
Wow. So, yun. Manood kayo ng show ni Dr. Reina Reyes.
Yeah, for the kids.
What, ano pang what else do you want to say?
Okay. Yeah, this, and then we have also advocacies. Yeah, the basic advocacy is to, yeah, to spread the word of science, and that scientists are cool people and that we exist. So I also have a blog.
Mm-hmm.
It's called Pinoy Scientists.
Oh, yeah.
And it's just PinoyScientists.com. And there's also a Pinoy Scientists Facebook page.
Mhm.
And every week we post a profile of a scientist who happens to be Filipino, and then they tell us about their work and what they do and their stories. So to show that yes, we exist and that there are many different ways to get there. There are so many different fields. Depending on your interests, temperament. So there are experimentalists, there are theorists, there are geologists, and then you can actually reach out to them. I mean, yun yung realization ko from my own story ko earlier, diba? Because there are no role models. Even a kid who is curious about science wouldn't think that it could be a serious career.
Yeah.
And so this is part
Especially
of that.
here, no?
So this is part of that, to show them that there are opportunities and role models who can help them.
What would your message to parents would be? Ano yung magiging...
Yes. It's really, but you're right. You got right to the heart of it, because I know that, because we know here in the Philippines, parents make still the biggest influence on the career, like choice of course and all that. And then when you see physics, anong gagawin mo, anak? Magtuturo ka. And there's nothing wrong with the teaching, right? But science, I mean, scientists teach, is what we do. We teach, but we also do, at the same time, we do research. To discover these new things, to study our environment here, air pollution. Jenny is studying the air pollution in Manila, which is really bad. And we need people to do that, right? So I guess be more open-minded and explore the careers of people in science and trained in science. Because even if you're trained in science and you don't necessarily become a science researcher, it just opens up a world of opportunities for you, even in technical or even non-technical careers. So, maybe I guess the message is just to be more open-minded, and then maybe just as my parents did, is to look for role models of people like me or like us here in Pinoy Scientists that have led successful and fulfilling careers in the sciences. It's just that I guess I understand where it's coming from, because it's like I understand, because, for example, I want to be a doctor. You understand this because we all need doctors, right? At some point in our lives, we went to the doctor, and then the doctor helped us. It's very direct, right? Or a lawyer. At some point in our lives, we would need a lawyer, and we would go to a lawyer, and they would help us. So an architect is the same, right? If you want to build a house, you need an architect. So I sort of understand why these professions are more popular or more easy to relate to or to understand, right? When you say a scientist, like, never in my life do I go to a scientist for help. It's like, because that's not what we do,
Para sa assignment.
Yeah, exactly. It's always just based on education, right? But that's not what we do. That's not what scientists do, right? Scientists are also educators, but that's another role aside from their role as scientists. And the role of the scientist is to understand phenomena, nature, and to understand. So if it's life, it's genes, then it's biology. If it's stars and galaxies, then it's actual physics. If it's fundamental particles, it's high energy physics, etc. So, by its very nature, it's really not something that directly, um, you would say, like relates or helps another person. But when you think about it, all the things that you use or what the doctor uses actually was developed by a scientist. An MRI machine, for example,
Oo nga, no?
is based on the science that a
A
scientist,
physicist.
a physicist came up
created
with.
that.
Exactly, exactly. So what we find is that the impact, um, yeah, the impact is not immediate, but it's it's breakthrough. It's a breakthrough, right? Because before you cannot see what's in your brain, now you can. And so it's more abstract. So that's, I guess, it's part of the education also, diba? That so sometimes it take generations, right? Because it would be that the parents would now um, let their children be artists, scientists, poets. Because also you don't go to a poet.
Well, actually, mga artist, problema
It's
talaga
even
yan.
different, right? Right? Because
Mm.
what do you contribute, right? But you contribute beauty.
Yeah.
And that's intangible and that's part of society. So just be more open-minded, hopefully.
Amazing.
And then um, at the end of the day, your child will be more successful if she's or he is passionate about or happy,
Mm-mm.
diba, aligned yung interest niya with what her or his career will be.
Mm-mm.
So even if you force him or her, I think,
Mhm.
to a different one, it's either eventually they will also not continue or not be as great as they could have been
Yeah.
with a career that's more aligned with their interests and effort.
And happiness is also important, di ba? Fulfillment because you're happy with what you do,
Oh, definitely,
di ba?
definitely.
In any chosen profession, di ba? So, whether you're a musician, you're
Definitely.
anything.
Definitely. And the thing is, no one goes into the sciences if they are not if they're not happy.
Oh, okay.
Right? I mean, I think that's the selection effect, right?
Mm-hmm.
Because if you go to a group of law students or medical students,
Mm-hmm.
then of course some of them would be that would be their interest, and that's why they're there. But also a lot of them would just be there because of other reasons. Because my parents want me to be here, right?
Mm-hmm.
But if you go to a class of physics students, no one told them that they should be there, right?
Ah, okay.
So we call it a selection effect because
Was that your case? Ganun ka ba?
yes, of course. I mean, you wouldn't choose this. Although, okay, in my case, I mean, of course, it depends on the physics. But for me, of course, I wanted to do physics. So you would argue that yeah, that is. On the other hand, that's why there are so few. And then you can ask, then maybe if there were no barriers, then maybe there would be more. Because if right now there are not actually a lot of, for example, where I teach at MIT, in UP, Diliman, there are like 100 freshmen that go into physics. That's a lot, right? And they're all there because they want it. So what more if there are less barriers to to young people who want to pursue they want, yeah. Because yeah, they watch Neil deGrasse Tyson, right?
Yeah.
I get a lot of messages like people I want to be an astronomer, I want to be an astrophysicist, I want to be a scientist, but it's more practical, yeah, to go into say engineering or some nursing, like a practical profession, right? And um, they have to make a choice.
Yeah.
Yeah, it's not an easy choice, but um,
Well,
we can make it easier.
we need the people to ano yan, maging mag-pursue for the future ng species, di ba?
Oh,
Kasi
definitely.
for the advancement of the human race. Kasi science is all around us eh. Parang right now, like these microphones, parang you just see the final product. But inside this is science that I don't understand. Na,
Of
di
course,
ba?
yeah.
Parang
And a lot of
never in the
research, and a lot of research and development is called R&D, right?
Yeah.
That goes into improving the little, all the technical aspects of it.
Yes.
And then maybe I'll just mention another thing we're doing to reach out to people about sciences is through art.
Mm-hmm.
And this is where we actually have the overlap
Yeah.
in the community because I work with artists and scientists, and we have a collective called we're called Trial and Error. Because trial and error is important to both science and the arts.
Mhm.
Trial and Error Art and Science Collective. We also have a Facebook page, and we have we make art, postcards, stickers, comics,
Mm-hmm.
um,
Comics.
that are inspired and based in science.
Mm-hmm.
So we'll actually be at Comiket next weekend. We'll have a booth. So if you're coming by Comiket, then please, say hi and check out our stuff.
Comiket, by the way, is uh, twice a year siya eh. Alam ko, summer and tsaka around this time, mga November.
October.
October. And it's Comiket, parang indie market siya of local creators, Pinoy comics. So, if you're namimiss nyo ng comics, you're not familiar with this, there's a thriving comics scene in the Philippines, and it is, well, ang proponents nitong Comiket are the guys behind the Comic Con as well. That's Comic Con with a K, yung Comic Con ng Pilipinas. And yeah, and they've been at it for more than a decade. I think 15, 16 years now.
Yeah, it's very
Yeah.
popular. A lot of people come through.
Yeah.
And we're happy because we get like people who, I mean, they don't expect to see science there. And then they say, oh wow, we see the elements, because we have like postcards of the different elements.
Mhm.
So they look for their favorite element. We also have the planets, and then they look for their favorite planet. And so we see directly how art makes science more approachable and fun, which is what we do.
Wow, thanks for for that effort. So, ano is this your idea or?
Yeah, it started with just this idea that you can use art to um, spread science, and then we got a bunch of scientists and artists together. So we have like around 8 people in our founding members,
Mhm.
and then from there it sort of spread now.
Yeah. Sabi ko magko-contribute ako doon.
Yeah, and of course, Gerald. Yeah, please. It's really fun. It's actually a fun group, talented group, and it's interesting. Actually it's interesting for the artist as well.
Yes.
Diba? How do you translate these
Yes.
concepts to art?
And you've mentioned some of them, and I know that some of them are science nerds as well. Diba? Like my pal Julius Villanueva, diba? He's what?
Actually, dinosaurs, yeah.
Oh,
Yeah,
dinosaur
yeah,
freak yun.
dinosaur,
Hi Julius.
Hi, Julius.
Sana mag-guest siya dito. Sana hindi siya mahiya. Anyway, so ano pa ba? Parehas tayong ano eh. The weather has been not very kind to apparently to both of us kasi parehas tayong
Tinatay naman natin.
Oo nga eh.
It's been yeah. I think we covered a lot.
Yeah. May last question ako about I keep one of the things that really about Neil deGrasse Tyson again that really captured me is this cosmic perspective idea, which is parang looking through things in a cosmic way, na the largest picture possible, diba? So, what are your thoughts about that?
Interesting. Um, also potentially uh, oh, just the simplest. I actually so I sorry, a lot of thoughts going through my
Yeah,
mind.
yeah.
I'm actually because teaching this semester.
Mhm.
I'm teaching a course called cosmology.
Mhm.
Um, but it's actually a philosophy course
Mhm.
in Ateneo. So I'm teaching it with a philosophy professor,
Okay.
Professor Mike Mariano. But our take on it is that, yeah, our take on it is that we discuss the science,
Mhm.
the scientific theories, and even with yeah, scientific ideas, and then we also discuss the philosophical ideas
Mhm.
because cosmology is, yeah, it's bigger than the science, right? I mean, if you're talking about the whole,
Mhm.
so in philosophy, cosmos is order
Mhm.
and the whole. It's not necessarily the universe as we know it,
Mhm.
but of course, in our modern scientific understanding, this is the universe as we know it. But then we also discuss like the multiverse idea that
Mhm.
our universe could just be one universe out of many, maybe an infinite um, number of possible universes.
Mhm.
And what does that mean, right? What does it mean for us, for our human lives? There's even this idea of parallel universes where you have different versions of you.
Mhm. Yeah.
And so all of these ideas, I think, challenge us and challenge these young students to confront um, their existence. And I think ultimately it's humbling.
Yes.
Looking at things cosmic perspective, you will realize how small we are, right? I
Mhm.
mean, we are on one rocky planet
Uh,
in this big,
a speck of dust
big
nga eh.
universe of everything. And then even in time, you know, our time scales are weeks, years, even. But then a lifetime is like 80 years if you're lucky,
Mhm.
right? But in cosmology, we talk about billions. Well, we know that the Big Bang happened around 13.8 billion years ago. And in that time scale, you know, one lifetime is a blink of an
Yeah.
eye, right? And so um, it really puts things in a different perspective.
Mhm.
And oh, again, it doesn't solve your problems, but it gives it's another way of looking at your life and yourself. And so um, I think I think we're doing a good job of doing that for the course so far. Um, and then I guess it's an invitation for everyone to get. I mean, because these ideas are out there, and
Mhm.
there's no more barriers to accessing them because of the internet and books. And
Mhm.
of course, here in a course, we actually make it systematic and we actually choose the materials for them. And then they have to write reflection papers and all of that, essays and all of that. But basically, it's an invitation for anyone to 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 take these ideas seriously and then see maybe hopefully broaden their perspective
Would you recommend
in life in
would you
general.
recommend the people to adhere to that to cosmic perspective philosophy?
Um, it's hard. I mean, it's not a philosophy, right? I mean, that's it's actually it could be dangerous, right? Because if you think about the logical conclusion, you might end up a nihilist,
Ah, yeah.
which is like nothing matters. So why don't I just kill myself or so? But science doesn't tell you that. Science have doesn't tell you what to do. And this is right. This is the thing, right? Science doesn't tell you what to do.
Mhm.
Science just tells you that okay, we observed and we made measurements and yeah, we see these galaxies and we know this is how big the
Mhm.
universe is. We know how the age of the universe and so you take that as you will. But I'm saying that you cannot be blind and not consider that, right?
Mhm.
So you consider that, and then you see how you move forward. But science will not tell you how to move forward. In fact, science, when people have used science uh, to to tell you what to do, then it's been bad. It's been really bad. People, the Nazis and all of that. But basically, I'm saying that science does not tell you what to do, right? But it gives you this perspective that hopefully you can take and do something good with your life. And let's put it that way. Because nihilism is not the logical conclusion of the cosmic perspective. Yes, I'm happy to say, because I've been there, I've been there, and you can get out of it, and you can still be a scientist, and you can still be uh, uh, um, um, a broad thinker. And in fact, I think that's a sign of even more maturity if you can, if you can truly understand all of the cosmic and let's say scientific perspective, but also see that as just one part of life. Then um, then you become a more mature person. Um, versus the person who doesn't have that, and then versus the person who just has that, right? Because that's also the danger, right? If you just accept that as the whole or as everything. And so, yeah, I guess the invitation is to partake in that, to take that seriously, but also not to get stuck there, because life is bigger than science.
Yeah.
And that's why your podcast has all these other guests
Yeah.
from different fields of life. And because that's what humans, it's what being human is all about, right? Science is just one part of being human. And so, and everyone can be part of that because we're all human. But it's not the end and be all of humanity. So, we need all kinds of
Awesome.
we need scientists, we need artists,
Yes.
we need good leaders, we need good politicians, we need good entrepreneurs. And so we want to build a society where we have all these talents being, you know, hopefully manifested in the world.
Yeah, and hopefully made into good use. Di ba? Para as history, di ba? Parang,
Definitely, because science technology can be used for,
yeah.
yeah, for any purpose.
Yun!
So this is the mature version. I mean, yeah, this is
Well, so, one thing that, one take on the cosmic perspective din is, ano eh, parang, sometimes, yung mga problema mo, parang sobrang stress ka, pero, if you look, like, let's say, yung mga, ang example niya, always has been when man, the first astronauts, got got of the Earth as a whole, and all of a sudden there were no borders dividing the countries, and it's just there. It's just there. It is one whole planet, and then all of a sudden, and everything, everyone that you know is in that rock floating in space, and then it's parang it's probably parang a surreal experience in Papa. Well, if you
and now we just take it for granted, right? And it's part of the environmental, Earth conservation movement,
Mhm.
because of that realization that that's all there is, right?
Yes.
But now we have flat earthers, so
Oh. Could you have a little bit of more to that? Flat earthers, so gusto ko talaga yan.
so what more can you say? You see, you have a picture of the Earth. It's round. But then, yeah, I mean, that's why this is important, right?
Yeah, that's why parang
Because
kailangan.
science is not, because science is really counterintuitive. Because when you look around, it's flat, right?
Oo nga, no?
And for millennia, people thought it was flat, right? Because it's how it appears, right?
Yes.
How can we tell you otherwise? It's flat, right?
That's
but then,
what common sense tells you.
yeah, exactly. So science is not common sense. And that's its power, and also that's why it's not. You have to educate yourself. You have to learn. You have to do the work. And and now it's just that a lot of people don't want to do the work, right? And it's a problem. And it's not just for science, but for anything, right? If you don't do the work, you don't get better, you don't get smarter, you don't get more mature. And so, in a way, it's not surprising to me because, yeah, it really looks flat. On the other hand, they come up with all these. I haven't really done research anyway, but apparently they have all. It's like a conspiracy theory, right?
It is. It is.
Conspiracy theory and then all of that. Um, so it's actually interesting from the point of view of parang like what does it take to be? Why do people believe what they believe? And then you go and get into all of that. But yeah, actually we need to understand that better also because so that we can somehow.
Maybe it's a psychological issue.
Yeah, it's more
diba?
like the need to believe and
No.
explain the world.
Or just stand out, magpapansin ka lang. Yun lang
To
siguro.
be different, to know something that others don't know. I don't know, but I'm sure there are.
But how frustrating is it that at this day and age, with all the photos and all of the technology advances that we made,
Well,
meron
it's
ganun?
it's actually interesting. For and it's not the only one. Ha? I mean, di ba? It's always been there. But it's just this particular one. It's really just silly, right?
So,
And so yeah, actually, in the large scheme of things, I don't think it's an. Yun nga, like you said, as long as you don't make decisions. But but
basta
I
hindi
don't know
ka.
where that goes, right? Because maybe in the next generation that a flat earther becomes president or something.
Oo nga,
I
no?
don't know what that
Oh my God. Well, at this day and age, everything's possible.
Right?
No.
I know there's this basketball player who believes that.
Kyrie Irving ba to?
Hindi si Jordan.
Ah, yun. Sino?
Jordan.
Si Jordan?
Yeah. But anyway, it's not the same. It's like there's really this groups of people who believe
The dinosaurs are fake?
no pets were pets.
Ah.
Something like this.
Meron mga dinosaur deniers din eh. Have you heard of them? Oo, di ba? Dinosaur
I'm sure there
deniers.
are all kinds.
Grabe.
I haven't heard of them, but I'm sure there are all kinds.
And the silliest I've seen yung forest deniers.
And then
There are no forests because the real forests were giant trees. And they were all cut down by giants.
Okay.
And their evidence is yung mga mountains na cut yung top.
So giants is like that.
Three stumps daw yun.
The
check
giant forest.
check mo nga yun. Yung, there are no forests. I-google mo lang yun kayo. Meron sa Google nun. Google Images. There are no forests.
People have been growing up in cities and so they have not seen forests. I haven't.
Images mo lang.
It's
Ayan,
also them.
ayan. Yung mga ganyan.
But it's also the flat earthers.
Yeah, Eric Dubay. Eric Dubay is siya mga pasimuno niyan.
So there's really this group na who are.
Yeah. Well, unfortunately,
But,
they are
also
growing.
there are UFO and aliens. I mean, that's another big community.
Yeah, well, at least it's fascinating, di ba? It's fun.
Okay.
It's just plain silly. Di ba? Di ba?
Distinctions na.
Alright. If it's Bigfoot, at least it's interesting. Di ba? Medyo, if it's messy, di ba? Medyo masaya, di ba? And it's kabubuhan lang talaga eh, di ba? So yeah, they're saying that these are giant trees,
Okay.
and all of these trees
these
were
are
cut.
giant trees.
Just silliness. Tapos basta natural rock formations. Anyway.
See? We gotta do no, yeah, no. I mean, yeah, there's so much.
Meron ng Flat Earth Philippines eh.
Because of YouTube.
Yeah, ganun talaga eh. Anyway. What else?
Hello, flat earthers.
Hi.
Welcome.
A question. May isang question pala oh my God, teka. My previous guest, Mr. Keith Sikat of he was the director of Alimuam.
Oh wow!
Yeah, he was here.
Wow!
He was here. He was my
Congratulations!
yeah.
I haven't
Yeah,
seen. We should see.
so
Where the collective is seeing if we can arrange a viewing or something.
really?
So baka maybe we can.
Ayan, hey Keith, show show Alimuam in where? Can you read the question?
Question.
Are there
Manifestations of certain theories, such as many worlds or parallel universe, separate wavelength exactly, that can be perceived, measured yet. Like deja vu. Could it be a manifestation of like parallel universes?
Mhm.
Yes, I guess the straightforward scientific answer is no. So, scientifically speaking, actually, that's the problem with these ideas of multiverses
Mhm.
or multiverse. And there are many versions, and actually, those are interesting ones because they're inspired, or I mean, it's like okay, so let's say for example this parallel universes separated by brains. It's a possibility in the scenario of string theory, scenario where you have more than three spatial dimensions. You have this 10 plus 1 dimensional universe where you have 10 spatial directions and one time direction instead of what we see as 3 plus 1, right? We just have 3 dimensions, height, width, and breadth. Uh, but string theory in itself is not has not been confirmed experimentally, and we cannot do it because it needs we need to um, probe super small scales, and for that we need big energies that we need. They say you need essentially the analogy is that you need an accelerator the size of the Earth,
Mhm.
which we do not have the technology or the resources or even motivation to do, right?
Okay.
So, um, so in that case, it's still in the realm of speculation. Um, you could argue that another idea of the multiverse coming from cosmology, inflationary theory, is closer to it. But again, the problem is we cannot probe um, that yet. So, but scientists say if you can somehow confirm or validate these theories, then you have to take their consequences seriously. And the consequence are, let's say, other universes. But by definition, again, from where we are, we cannot observe these other universes from our universe.
Okay.
So, well, actually, okay, what to make it concrete, we have an observable universe.
Yes.
Observable universe is the region of space from which light could have had time to reach us
Yes.
over the age of the universe, which is like 40 billion years ago. But because of the expansion of the universe, this region of space is actually around 90 billion light years across. So it's very big, but it's still a finite size.
Mhm.
90 billion light years across.
Yes.
It take light 90 billion years um, to cross the observable universe. So, so we cannot even travel that far, right?
Mhm.
It's not about even travel. It's like the light from outside that region
Hindi pa
cannot reach us,
nakakarating.
right? Okay, tomorrow then this expands one day at a time. I mean, one every over time it will expand, right? But these other universes, let's say from the inflationary theory, would be actually that's the simplest version of the multiverse. Just other regions of space
Mhm.
that's outside our observable universe. Because when scientists say universe pala, we mean the observable universe.
Mhm. Yeah.
Why? Because by definition, science is based on things that we can observe.
Okay.
And so, when we talk about the universe, we need all this, the scope, the region of space that we can observe. And so by definition, everything outside that is outside the scope of science. I mean, that's what one straightforward definition, right? But our theories, like for example, inflation theory, would say that actually this region of space is just a small part of the whole space that inflated early on. And so there are other regions, and these other regions would be other universes.
No.
But I guess to answer, I mean that's the parang straightforward physical example is that by definition, since we cannot get any signals from these other universes because of the barrier of the speed of light, we cannot observe them. But okay, in sci-fi, you could imagine that maybe there's some mechanism that can cross like between universes, like wormholes and stuff like this, or maybe even to other planes, but we're so far from that. And in this question about deja vu, again, it's not thought as connected to the multiverse. But the same thing, of course, is that we don't understand consciousness, right? So that's the big question mark. It's still, it's like a holy grail of science, so is to understand consciousness. And of course, so that's a fascinating thing. And even in their class, we started, and students figured out that what if consciousness is what can travel through these universes, stuff like this, right? But we don't know. So right now it's like everything there is speculative. In general, as I said, it's usually not connected because it's cosmology versus the brain. Because the scientific straightforward road is that it's just neurons firing. But then what do we perceive as? And then you go by. So this will bring us to philosophy. But basically, the answer, Keith, is that there are no manifestations. There are no physical. If the question is there are manifestations that are psychological, the answer is no. The expectation of scientists is that we can probe these theories through cosmological observations, astronomical observations, cosmic microwave background, or the accelerometers of the accelerators of the future. But that's our current 21st century understanding of science, which could be very different from
next century.
next centuries.
Just a few decades nga lang baka, diba? That's the best thing about science. Parang if you don't, even the brightest scientists, kung hindi nila alam, they don't have sufficient data, they will not say they know, diba? Unlike on other institutions, diba? Like, parang, hindi, ito yung batas. Diba?
It's a value.
Diba? So that's
and it's a part, and it's the nature of science that it progresses, which should make it powerful in a way, because what we know now, Galileo didn't know.
Yes.
Right? Even at the height of his, that era. And then that gives us, that's why we say, we are humble enough to say that there's so much we don't know, and that the next generations could probably, and we hope, would keep building on it and then find more amazing things.
It's the message of science, I think, is that when you don't know, parang you ask questions, and then if you have the fortitude to do experiments and prove things,
and then find something, figure some things out, and then you tell the world, and then they will build upon that.
Yes.
So, and science fiction, of course, is also a very fascinating role because it could take us to
a lot of theories started from science fiction, di ba?
Yeah.
So it's
And yeah, it pushes the science to sometimes logical um, um, extremes, for example, or just exploring different possibilities. So yeah, looking forward to seeing Alito.
oh yeah. Oh, Keith, please do the arrangements. I'm sure he would gladly show that film to anyone who would sit down and watch. I'm sure. So yeah, I mean, so I'll just invite you next time again. Hopefully, we can do this again one of these days. And like I said, I am very honored to have you as my guest in my little podcast
Thank
thingy.
you. Yeah.
And
Thank you for having me.
yes, and yeah, thank you for coming back home. And it is I mean it's a huge thing that I mean not a lot of people were actually surprised that we have an astrophysicist and Filipina, 'di ba? It's syempre 'di ba? Parang the if there's a stereotype parang you would think men would be the ones no ganyan. Pero here you are and you have accomplished a great feat with what you did. And right now you're in data science, diba? Maybe we can discuss that next
Next
time.
time.
Ang haba na no. Ang haba nun. Ang haba nun, diba? All right. So thanks everyone who watched. You can if you're just watching right now, you can this is gonna be recorded, so you can watch again later. And again, if you enjoyed, please share. It's not how many times have you seen an actual scientist being interviewed on anywhere in Filipino scientists at that, and this is a I always say this, and parang, this is why I created this podcast to have people like you that has wonderful messages and powerful messages, and who rarely gets the avenue to to discuss these things. Diba?
With
Parang,
ample time
yes. And then hindi lang sound
and,
bites.
and depth. Yeah.
Yes. So,
Thank you for
hopefully,
opportunity.
hopefully, madaming manood. And,
And you invite more scientists to your show.
yes. Thank you, Reina. It's an honor. And with that, Powerful Komiksman podcast. Bye-bye. Woo!
Yeah.
That's amazing.